Hello to everyone. I am Dr. Pratibhadevi. Today we are discussing about the embedded system design. It is one of the curriculum topic of the electronics and communication engineering students in the sixth semester course. This typical embedded system is the module 2 or unit 2 content. So what is the core of what is the embedded system? You all know already. What is the core of embedded system? It is going to be sensors and actuators and the communication interface between the sensors and actuators. In between to store or save some of the information, some of the data, we need a memory. So totally core of embedded system is going to be the memory, sensors and actuators, communication interface. So basically we should know before proceeding what is the sensor and what is the actuator. So as every computational unit requires one input and output device, here sensors are going to be the inputs and the actuators are going to be the outputs in typically embedded systems. So here is the block diagram or typical embedded system diagram. In the real world, the embedded system contains the system core that is going to be either FPGA. FPGA stands for Field Programmable Gate Array, or ASIC, Application Specific Integrated Circuit, or DSP, Digital Signal Processor, or SoC, that is a system on chip. That means a microprocessor or microcontroller can be a system core, that is the processor part. Next, memory is required to store the software or programming or the data to be required for computations, or it may be observed data also. And IO input ports, that is sensors, output ports or output devices are going to be actuators. For example, these are the two examples shown here. And other supporting integrated circuits and subsystems for the interrupts, clock generation, timers, etc. are going to be used based on whether the system core or processor is microprocessor or microcontroller. And communication interfaces like the cables are going to be used to do the connection among these all devices. Coming to the processors. So here we are going to have the different categories of processors where these all can be used in the embedded system. So embedded system falls into any of the following categories. The first category is the general purpose and domain specific processors. They are going to be microprocessor, microcontrollers, and digital signal processors. Secondly, programmable logic devices. They are going to be called as the PLDs. And thirdly, application specific integrated circuit ASICs, and fourth one is the commercial off-the-shelf components, that is COTS. General purpose processors, in short GPPs, versus application specific instruction set processors, ASIPs. So the points are going to be like this. General purpose processors, GPP is a processor designed for general processor or general computational tasks. Like it is going to be used generally. So it is going to have the capability to do all the tasks or operations required for all the peripherals connected to it. So the processor is not specifically meant to do any one task. So that is the GPP. GPPs are produced in large volumes and targeting the general market. Due to the high volume production, the per unit cost for a chip is low compared to ASIC or other specific application specific ICs. That's when the ICs are general purpose, they are manufactured in bulk, and the per unit cost is going to be smaller as fabricated in bulk. A typical general purpose processor contains an arithmetic and logical unit, that is what we call as a ALU, and also the control unit. So ALU plus control unit is going to be the CPU. Next, to be considered for the application specific instruction set processors, they are going to be ASICs, are the processors with architecture and instruction set optimized to specific domain or application requirements like network processing, automotive, telecom, media applications, data signal processing, control applications, etc. For example, to say automotive domain example is the car, or it may be truck, it may be any other vehicle also. Telecom, it is a we can say example as the Android phone. Uh, Similarly, based on the and if you take the home automation, or that is going to be a refrigerator as the example. The application specific means they are going to do only that particular task. If we cannot use those processors for any other specific task to be carried out, because the hardware inside that IC is going to be designed according to that functionality to be carried out. Similarly, the difference between the microprocessors and microcontrollers, before going to deal with the differences, let us see what is microprocessor. You all know already. Microprocessor is the processor. Before the microcontroller was evolved, the microprocessor was the on demand. It is going to have the central processing unit, that is a combination of ALU and CPU, memory unit, and it is going to have all the peripherals externally connected to the processor IC. So it was not having internally the capability to include the peripheral units like a memory, interrupt controller, etc. So the Intel is the first company which manufactured a 4-bit microprocessor, that is Intel 4004, during the 1971 November. Then what is the microcontroller? Microcontroller is the upgraded version of the microprocessor, where internally the microcontroller contains microprocessor plus the rest of the peripherals like a ROM, on-chip ROM, RAM, flash memory, I/O ports, timer, interrupt control, etc. Microcontroller can be considered as a superset of microprocessors, right? So microcontroller can be general purpose or is application specific also. So since next to say about the microcontroller contains all the necessary functional blocks for independent working. They found a greater place in the embedded domain in place of the microprocessors. So microcontrollers are completely replaced the microprocessors. So microcontrollers are compared to microprocessor, they are cheaper, cost effective, and are readily available in the market. Texas Instruments TMS 1000 is considered as a world's first microcontroller. So here are specifically the differences between the microprocessor and microcontrollers. So all the things already you know it. So these are the differences. Then digital signal processing processors are the application specific processors. They are going to be very faster, fast enough compared to the normal microcontrollers. So they're going to use the data handling required in audio video processings. So this is about the typical embedded microcontroller or typical embedded system constraints. What exactly is the difference between the microprocessor and the microcontroller? Thank you.